Good day and welcome back to my channel. Today we will be looking at derivatives from first principles. A derivative of a function is an equation for the gradient at any point in a function. So essentially, if you have a function and you find the derivative of that function, it's an equation to find the gradient at any single point in that function. The derivative of a function is denoted as f prime of x. And the derivative of a function is equals to the limit as h tends to 0. We looked at limits in the previous video. The limit as h tends to 0 of f of x plus h minus f of x all divided by h. This is the equation to calculate the derivative of a function. Let's look at an example. The first example, we look at the function f of x is 4x plus 3. And here we have our equation for the derivative of the function. I'll be simplifying f of x plus h and f of x separately in order to make it look tidier. So, f of x is just from our equation, which is 4x plus 3. And f of x plus h, well, f of x plus h essentially means that wherever x is in the original function, we're going to substitute x plus h. So, instead of 4x, it's going to be 4 into x plus h plus the 3 that was originally there. And just to simplify that out, I'm going to distribute the 4 into the bracket, so we're left with 4x plus 4h plus 3. Now substituting in for f of x plus h and f of x, as we determined in the previous slide, we're left with the limit as h tends to 0. Now just a reminder, we keep on writing the limit as h tends to 0 in every single step until we substitute in 0 for h. So f of x plus h was just 4x plus 4h plus 3, and f of x was, so the minus sign and open our brackets, f of x was 4x plus 3. And this was all divided by h. Now if we just distribute the minus sign in, we have the limit as h tends to 0. We can see that once we distribute the minus sign in, it's 4x plus 4h plus 3 minus 4x minus 3. Once we distribute the minus sign in, we can see that the minus 4x will cancel out with the 4x, and the positive 3 cancels out with the negative 3. And this is all divided by h. So we're just left with 4h all over h. And now we can cancel out the h's. Then in the next step, we're just left with 4. And if we substitute h is equals to 0 in 4, so it's the limit as h tends to 0 of 4. And since there's no h in this here, that means that our final answer is just 4. The next example is f of x is 3x squared minus 1. So as we've done previously, we're going to find out what's f of x plus h. And we said that wherever x was, we're going to substitute x plus h. Now remember, in this question, x is squared. So it's going to be 3 into x plus h all squared minus 1. And we're going to simplify this out. Now remember, we have to first simplify this bracket before we distribute 3 in. So it's going to be 3 into first times first is x squared, 2 times first times last is plus 2xh, and last times last is plus h squared minus 1. Now we distribute 3 into the bracket, so it's 3x squared plus 6xh plus 3h squared minus 1. F prime of x is equals to the limit as h tends to 0 of 3x squared plus 6xh plus 3h squared minus 1 and then minus our original function, which is 3x squared minus 1, all divided by h. Now, as we can see, when we substitute, when we distribute the minus sign into the bracket, we'll have some cancellations again. So 3x squared plus 6xh plus 3h squared minus 1 minus 3x squared plus 1. Now the 3x squared will cancel out with the negative 3x squared, and the 1 and the minus 1 will go. This is all divided by h. So we still write the limit as h tends to 0, as we didn't substitute h in as yet. And we have what's left is 6xh plus 3h squared. Now remember, we want to get rid of this h as a denominator so that we can substitute 0 in. So we're going to have to take out h as a common factor, and we're left with 6x plus 3h. This is all divided by h. Now these h's will cancel out, and then we have the limit as h tends to 0 of 6x plus 3h, which is equals to, when we substitute 0 into 3h, this will just be a term that's only 0, and our final answer would then be 6x. Now, as we've done previously, we found out what f of x plus h was before we substituted it into the derivative formula. So, in this example, f of x plus h is simply equals to 1 over x plus h, because wherever x is, we're going to substitute x plus h. Now we can substitute it into our derivative formula, which is, once again, f prime of x is the limit as h tends to 0 of f of x plus h minus f of x all over h. And that is the limit as h tends to 0 of. Now f of x plus h is just 1 divided by x plus h, and f of x is 1 over x, and this is all over h. Now, this is a bit of a different format compared to the previous examples. But we notice that in the previous examples, we just want to factorize or simplify so that we can get rid of this h as a denominator. Why? Because if we substitute 0 for h as a denominator, we'll get an undefined number. So we want to basically get rid of h as a denominator. Now, how are we going to do that now when we have fractions as a numerator? Well, the first thing we're going to do is that we're going to do LCD of the two denominators in the numerator here. So, this is still the limit as h tends to 0. Remember, we can only remove this once we substitute h is equals to 0 into the equation. So, doing a lowest common denominator in the numerator of this fraction, our lowest common denominator is x into x plus h. And our numerator is, now here we have x plus h, so what's missing is x, and then minus. Here we have x, so what's missing is x plus h. And this is all divided by h. Okay, now if we distribute this minus sign in, we'll see that it's going to be x minus x, which is 0. And then we're going to be left with minus h. So, I'm just going to write this step a little bit differently so that you can see what I'm going to do next. So, the numerator here becomes minus h all over x into x plus h divided by h. And this divided by h is essentially the same thing as multiplying by 1 over h. And this h and that h will cancel out. And now we don't have only h as a denominator. And now we can substitute 0 into the expression. So, it's the limit as h tends to 0 of minus 1 all over, and I'm just going to distribute this out, x squared plus xh. Now once we substitute the limit as h tends to 0 in here, this term goes to 0. And we're left with minus 1 all over x squared. And that's our answer for our derivative of f of x. So the exercise says, find the derivative of the following from first principles. And it has 4 questions here, and the answers are alongside so that you can check if what you did was correct. I hope you enjoyed this video. And if you enjoyed this video, please give it a thumbs up and subscribe to my channel.